Riga, Ogden, and Palmyra, and have an interest in this ordinance and ensuring that it allows a reasonably designed wind farm to be built in Riga Township. And we were particularly concerned about the language that you have included in the ordinance with respect to sound, and we engaged Peter Goldberg of Tech Environmental, a well-known acoustic practitioner, to look at the ordinance and then give recommendations based on his views on that. I have a letter that summarizes the presentation that Peter's going to give tonight, along with a copy of the boards that he's going to use. And I'd like to present that to you now, and then I'll hand the microphone over to Peter Goldberg.
Thank you, Doug, and thank you, Chairman Cart, and members of the Planning Commission for the opportunity to speak before you this evening. I really appreciate it. My name is Peter Goldberg. I am a noise consultant with 35 years of experience. Let me just give you a little bit of my background before I get into what I'm here for tonight. I have degrees in mathematics from MIT, degree in atmospheric science from the University of Michigan. I'm an associate member of the Institute of Noise Control Engineering and the Acoustic Society of America. I've worked on wind energy projects here in Michigan and other states. I've also served as a consultant to town zoning and planning boards in 3 states in helping them write wind ordinances, so I'm familiar with the topics. John Deere and Great Lakes Wind asked me to review the draft ordinance that you've been working on. And I'm here tonight to present that review and some of the concerns I have about the draft ordinance as it relates to utility scale energy systems. Specifically, page 14 of your draft ordinance, which addresses itself to audible sound from those types of wind systems. My particular concern is the use of an incremental limit on page 14, which is an incremental limit above, quote, the lowest ambient sound level. For several reasons I'm going to go through, this type of sound limit is unworkable, and it represents an exclusionary ordinance. It would likely preclude wind energy development in Riga Township. Now, the significance of the term lowest ambient sound level is not apparent to most people. And so I want to spend a few minutes trying to walk through what some of the key terms are in the draft ordinance, so that when I speak about decibels and I speak about ambient sound level, we all know what I'm talking about. So I'm going to start with this graph, and I hope everyone on the commission can see it.
Could you turn that graph so that the rest of the people can see it?
If I turn it, then the members of the commission will.
You can.
I'll be glad to. Perhaps you could help me by turning it. Yes.
It's kind of, I don't know if they can all see it. Is that better? Can you all see it now? You can read it?
Okay.
I don't think people in the back of the room can see it.
Is that better? Thank you, Mr. Super. Thank you. Okay. The human ear can sense a wide variety of sound. And to put that on an easy to understand scale, we use the decibel scale, where the threshold of hearing is 0, and the loudest sound that we can hear is 120 decibels. So in everyday life, the sounds that we hear are usually in the range of 30 to 90 decibels. A nice property of the scale is that every 10 decibels increase on the scale represents a doubling of loudness. So I'm going to give you an example. If I walk over to this gentleman, and he and I are having a normal conversation, he's hearing 65 decibels right now. So if I raise my voice so it's twice as loud, he's hearing 75 decibels. So every 10 decibel change on the scale represents either a halving, if you're going down, or a doubling of loudness as we perceive it. So that's why it's a very easy scale to understand. This chart shows some of the typical sound levels that we experience in everyday life in a quiet rural area without significant traffic, which is what would describe Riga Township, I believe. A quiet rural area at night has average sound levels of about 35 decibels. A quiet suburban area would be 45 decibels. The freight train you might hear in the distance would be 50 decibels. On a summer night, crickets and tree frogs can easily produce 55 decibels in a field when they're singing. And as I was just demonstrating a moment ago, conversational voice at an average speaking level is about 65 decibels. If you're standing by a road, a car passes by, you'll hear 75 decibels. If it's a truck, 80 decibels. And what I want to show you is that there are many events in everyday life where we hear sounds louder than 45 decibels, representing a quiet suburban area, or 35, a very quiet night in a rural area. If you're 50 feet from a tractor or combine, 85 decibels. Let's say you're pushing a lawnmower around in the yard, you're hearing 95 decibels. So that just gives you a review of some of the typical sound levels that we hear. Now, with this chart as a reference, the question I'd like to answer is, what sort of outdoor sound level limit should apply in residential areas? The Planning Commission is probably aware, I'm sure, that the state of Michigan wind energy guidelines recommend a limit of 55 decibels at residential properties. The Environmental Protection Agency, EPA, recommends a residential outdoor noise guideline of 55 daytime and 45 decibels at night, the lower limit to prevent annoyance and to prevent sleep disruption. The World Health Organization recommends a limit of 45 decibels at night outside of a bedroom to prevent sleep disruption and to ensure that people could sleep with their windows open for air. On this project, John Deere will design its project to ensure that maximum sound levels outside of any person's bedroom window at any location in Riga Township will be no more than 45 decibels at any time. That is a commitment that John Deere is making on this project. Now, with this introduction, how much sound does a wind farm produce? Apologize. The commission members, there is a copy of all these slides in the back, so you can follow along even if you can't see this graph. All right. Pardon me for introducing a graph. I'm a mathematician. I like to draw these things. So how much sound does a wind farm produce? It depends on the type of turbine, how closely they're spaced, and how far away you're standing from that turbine. This graph shows you the maximum sound level you would ever hear standing directly downwind of a Vestas B100 turbine. And the Vestas B100 is the turbine that John Deere at present plans to use in the project that would include Riga Township. So let me show you. This is the distance standing downwind along the bottom axis here. And this is the sound level, decibels, that we've just been talking about on the vertical axis. And the green line shows this, that at a distance of 1,000 feet, roughly 45 decibels for a B100. The highest sound level you would ever hear. Distance of 2,000 feet, about 38 decibels. Now, let me tell you, this assumes that the turbine is producing maximum power. That means that the wind is at least 22 miles an hour up at the hot pile. So it's spinning at a very high rate of speed. It also assumes the most favorable conditions for sound propagation. Sometimes when the atmosphere bends sound waves one way or another, but this assumes the most favorable conditions for sound propagation. It assumes you're standing directly